Hello friends! In the first section, we started the project, imported some assets, and created a functional floor with collision. In this section, we'll focus on creating a character for the player to control and play with. To get started, we'll first build the node structure of a typical character. In the scene panel, click the plus button to add a new node to the scene tree. Search for character body node 2D and create it. I'll rename this node to the name of my character. Just like with the floor, there's a warning. This node has no shape, so it can't collide or interact with other objects. We already know how to remedy this problem. Simply add a collision-shaped 2D node and define its shape. The warning reminds us that we must create a shape resource in the inspector. Most characters in games use capsules as their collision shapes because they are easily adjusted to encompass the overall shape of a humanoid and are simple for the engine to work with. By default, new nodes are added at the scene origin in the upper left corner. Let's zoom in on the new nodes. We also need to be able to see what the character looks like. So for that, we'll add another child node to the character, a sprite 2D. We saw in the previous lesson that there is a texture property in the inspector panel for sprites, but this one is empty. Browsing through the Treasure Hunter's asset pack, select a character sprite to use by default. I don't want my character to be equipped with the sword by default, so I'll select from the Without Sword folder and pick Idle 1. Now we can see the character as it will be drawn in the game, but it is blurry. That's because Godot's default project settings are not optimized for pixel art. To fix this, select Project from the menu bar, then Project Settings. There are a lot of project settings, and depending on your version of Godot, they may not be organized or named the same way. If you have trouble finding any project settings, there is a search bar at the top of the window labeled Filter Settings. We need to find the settings for rendering 2D textures. Then change the default texture filter from linear to nearest. This will stop the graphics engine from trying to smooth the texture and simply draw it as is on screen. With the changes made, we can close the window, and now the character is drawn in perfectly defined pixels. When working with pixel art, this is generally the preferred aesthetic. With the red X and green Y axes marking the scene origin, we should assume that the character's origin will be at their feet. So let's drag the sprite up until the red X axis acts as a floor where the character will stand. Make sure that they are also centered about the green Y axis. To make adjusting the collision shape easier, I'll reorder it to be below the sprite in the scene tree, but still childed to the character. This also determines what order the nodes are drawn on screen. With the collision shape in front of the sprite, it's easier to move and adjust its size to match the character. Remember that the bottom point of the collision capsule should line up with the character's feet and the red X-axis for the character to stand cleanly on the floor, and should also be centered about the green Y-axis. In 2D games like this, it is generally considered good practice to make the collision shape smaller than the character. This will prevent the player from getting hit by attacks they would perceive to be near misses and allow them to get closer to the environment. Before the next step, make sure your file system panel is focused on the root resource folder. New resources will be created in the last folder you interacted with in the file system panel. You can collapse any open folders and click on the blank space if you're unsure. With that done, right-click on your character. We can take any branch in our scene tree and save it as its own scene. I'll name this new scene after the character. It's already done since it will use the node's name as the new scene name by default. Now Roger is their own scene, separate from the scene we've been working in. Roger's node in the scene tree has a clapperboard button, and the child nodes have been hidden. Clicking on the clapperboard opens Roger's scene. This allows us to edit Roger in isolation, and any changes we make here will be transferred to all scenes containing Roger. In the main scene, we can now move Roger from the scene origin down to the floor where they will be drawn on screen. If we run the current scene, we can see Roger hovering above the floor, but he should probably fall down to the floor from gravity. In order to make Roger behave like a character, we need to add a script. So switch to Roger's scene and select the root node. Then click the scroll with a plus button to add a new script. It's good practice to write common behaviors as generically as possible, so this script should not be Roger. Instead, I'll name this script Character, and write the script in a way that it can apply to any character, not just Roger. Godot offers a default template for scripts attached to certain nodes, so we'll see what this template has in it. By default, the script will inherit the behaviors of the node type it is attached to, in this case, a character body 2D. And we will be writing all of our scripts in Godot's native language, Godot script. Click Create to create the new script and attach it to the node. The main panel will automatically switch to Script View and open the script for editing. As you can see, the template already has several features. The character has a speed and a jump velocity. These are measured in pixels per second. There is also a gravitational force, which is being set by the project's settings. In the physics process function, we can see that the gravity is applied to the character if they are not on the floor. A jump button has been implemented, adding jump velocity when pressing UI accept, which is the spacebar. And there is directional control for left and right directions, allowing the character to move and stop. Move and slide is a built-in function which will take the character body's position, velocity, and external forces, then determine where the character will be after delta time has elapsed. With the default settings, this code will run 60 times per second. If we run the current scene, we will see Roger fall from the scene origin. But this is Roger's scene. It's not meant to be played. Switch back to the main scene and switch the view to 2D. Playing this scene, we can see Roger immediately fall to the floor. Pressing the spacebar causes Roger to jump. Pressing the left and right arrow keys will move Roger left and right. This implementation of controls isn't very good, but does offer a starting point from which we can build our game. Now we have a basic character being drawn on screen with basic controls and physics. In the next lesson, we'll focus on improving our player controls. I'll see you in the next lesson.